name is Bob Spearing. I'm MUFON's Director of International Development, and tonight we'll be talking about the newest interstellar object to enter our solar system, and that would be 3I Atlas. My guest tonight is Mark D'Antonio, who is MUFON's Chief Photo Analyst. Mark runs a number of companies, including FX Models. He runs Sky Tour Live, which live streams the Arizona night sky most clear nights. He's a well-known photo analyst on a number of television shows, and he's an astronomer. My other guest is Greg Sisko. Greg Sisko is a state section director in Illinois. He is also an astrophotographer. He's a member of the Fox Valley Astronomical Club in Illinois, and he also is retired from the IT team after 40 years with Fermilab. So tonight we're going to be talking about 3I Atlas. Initially, Avi Loeb, a professor at Harvard, came to some UAP fame when back in 2017 an interstellar object, Oumuamua, began passing through our solar system, and Avi Loeb made the claim that it could possibly be alien technology. That pretty much put him in the realm of public opinion. He followed up in 2023 when he was financed to do a Pacific Ocean expedition looking for possible fragments of an interstellar craft. It turned out that what they found were these small magnesium balls at the bottom of the Pacific Ocean, not necessarily anything alien. And now that 3I Atlas has entered our solar system, Professor Loeb suggested that this also could be possible alien technology. He has a scale of 1 to 10, with a 1 being least likely to 10 being most likely, and he places this as a 4 on his scale. So I'm going to bring in my guests here. We'll start with Mark. And Mark, pretty much, could you tell us about interstellar objects like Oumuamua and 3I Atlas, where they come from, where they're going?
Sure. One of the things we have to understand is, how do we know they're interstellar? Okay, that's sort of the big deal, right? You have this dot of light moving through the sky. How do you know it's interstellar? How do you know it didn't come from our Oort cloud, the cloud of comets that's in a sphere around our solar system? How do we know that? Well, if a passing star over millions of years dislodges something from the Oort cloud and makes it start its long journey into the inner solar system where we see it as a comet, it can only reach a certain speed, a certain maximum speed. But when something comes in from outside our solar system, it's already moving at a relatively high speed. So when it passes through the Oort cloud and continues on into our solar system and then into our inner solar system, it's moving at a fairly high speed. And that's how we know, by their speed. Their trajectory isn't necessarily going to tell us where they're coming from, but their speed does, because nothing can move as fast as this is, which is like 130,000 miles an hour, roughly. That's a pretty fast speed, considering that most comets move like 3/4 of that speed at the fastest when they come in from the Oort cloud. So, one meaning first and I meaning interstellar, Oumuamua, came in and was on its way out when we first saw it. We weren't set up to really look for these kinds of things, and now we are. And Oumuamua, at first, it suffered a massive number of false information flags flying all over the internet. Oh my gosh. They thought it was 700 feet long and 70 feet wide. Okay. Well, yeah, in profile, but it was actually a pancake, and it was tumbling as a tumbling pancake. And in the astrophysics arena, they never thought it was long and thin like a spindle. They knew it was a pancake. This is why Avi Loeb then said, maybe this is a solar sail, a defunct solar sail. Now, solar sails are an interesting concept. We came up with one too, meaning we, the human race. And what they are is a long, giant, think of it as a thin sail made of some type of thin material, mylar, plastic of some kind. And the sun's rays striking it, it's not just rays that are striking it, it's particles protons and electrons in the solar flux, the solar wind, constantly hitting that thing, bam, 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 bam. And when it does that, it would accelerate it. So a solar sail was a somewhat viable but slow method for sending a probe somewhere. And it goes in the direction of the sun's rays, the sun's solar wind. So they thought maybe that Oumuamua was a potential solar sail. We didn't really get any good photographs of it to know. We just had the data of it leaving. And when it left the solar system, it seemed to do some different things that a comet wouldn't do, and that an asteroid, an errant interstellar asteroid would do. So that is the reason that Avi wrote the book, Extraterrestrial. It was extraterrestrial by its very nature, actually. And so, was it a alien device? Well, probably not. And even he would say that he would err on the side of caution. I've talked to him in the past about it. And one thing too is that after Oumuamua came and went, then the internet buzz died down, and then 2I, the second interstellar object, Borisov, came through. That one was never questioned. It was a comet from the very first, and it and Oumuamua came from a certain direction, which was not unexpected, but then again, didn't put it into the realm of very high strangeness. Then came 3I Atlas. 3I Atlas, this came in parallel to our solar system, came in along the same plane as our solar system disk. Okay. Now, how that worked was, and I'll show it, I got images to show later. The solar system sits about like this, about 62 degrees to the galactic disk, like this, right? From the side, the galactic disk, we bisect the galactic disk in a sense. With our solar system, now the galactic disk is very thick, top and bottom, but we're like this sideways to it effectively. And 3I Atlas is coming along this direction like this. So it's come in and it's going to circle around the sun, not circle, but get bent by the sun in its path and keep going. So it comes from the galactic disk, and that's different. So because it's so different, it means that the comet may look very different from what we're used to, and that's certainly what we're seeing.
Okay. Greg, some of the unusual aspects of this thing is that it has tails, like a comet would, but they're not tails in the usual sense. Could you explain what's going on with Atlas, if it's a cometary object?
Well, the thing about so Avi Loeb, some of the anomalous things that Avi Loeb had mentioned about 3I Atlas was the tail was not pointing away from the sun, but it was pointing toward the sun. A year ago, there was another comet that Atlas had discovered, and literally about a year ago. And since I'm an astrophotographer, I imaged that comet, and I thought there was something wrong with my optical system because I had a line coming out of the front of the comet. And I did some Google searching, and sure enough, there's what's known as an anti-tail, and that happens when the Earth is in the right perspective relative to the comet and the sun. You see this anti-tail, and I would have thought that Avi Loeb would have known about that. Any astronomer would have known about that. So when the comet coming out of the front, or the tail coming out of the front of the comet was mentioned, I was astounded that nobody said anything about an anti-tail. And up until this video right here, this is going to be the first time I think anybody has even broached the topic of an anti-tail being the reason for the tail being observed coming out of the front of 3I Atlas. So I would like to see an explanation for that if it's not an anti-tail. I would also like to see an explanation for the fact that Avi Loeb said that there wasn't enough interstellar matter to be able to produce an object as large as he believes 3I Atlas is. And that was the other anomalous thing. When the Hubble Space Telescope took a picture of 3I Atlas, it was so brilliant that Avi Loeb was saying that in order for 3I Atlas to produce that amount of light from reflected sunlight, it would have to be of a certain size that there wasn't enough interstellar material to create an object that size, and that makes it anomalous.
But
Uh,
now,
the,
oh, I'm sorry. Keep going.
the The one thing about Oumuamua that made it anomalous is, yes, the solar sail part that Mark mentioned, yes, that was mentioned, but what got everybody's attention was the fact that as Oumuamua went around the sun, it started accelerating, and when objects move away from the sun, or any when when objects move away from a gravitational body that is keeping them bound, they slow down, they don't speed up. So apparently Oumuamua sped up, and that was the anomalous thing.
And is there a rational explanation why it may have sped up?
It could be a solar sail. It could also be an alien space, an alien spaceship. So Avi Loeb was kind of right on Oumuamua, okay? But now with Three Eye Atlas, with everything that's been said, it's almost like Chicken Little and the sky is falling. I haven't seen what I would consider a good enough explanation for anything yet. The image that Hubble took is identical to many images that my friends and I have taken over the years of comets in general. It didn't look like anything to get excited about. So I'm really puzzled why he's doing that. I'm just going to go ahead and say it, I guess. I just don't understand.
Okay.
I'm not a scientist, but since I worked at Fermilab for 40 years, a lot of my friends are. So, and a lot of them actually worked on the James Webb Space Telescope, actually. There was a contingent at Fermilab. Most of the physicists there are now astronomers. So, yeah.
You know, I was going to say, Bob and Greg, we've also, with our SkyTour live stream observatories, we've taken pictures of comets. We're going to be doing some tonight after this, I think, if it's clear out in Benson, Arizona, where the Sonoran Desert, the opposite for both buildings have both open at the same time, and we're going to take pictures of some comets. Actually, one of them we took a picture of a couple of years ago was comet Tsuchinshen Atlas, and Tsuchinshen.
That's the one I'm talking about.
Okay, because I have the anti-tail on that one as well.
Right. That's the picture I had.
Yeah.
The
anti-tail is simple to explain once you know what you're looking at. And what happens is, as a comet's going in its path, it's curving, right? And it's leaving dust behind in its orbit. Now, if it curves enough, you might actually see that the tail starts to swing around. And so in front of the comet, from our perspective, we see the other end of its tail curved way out in space. And so that other end of its tail looks like it's in front of the comet. So we could be looking at the same type of thing with this particular object, with Three Eye Atlas. So I basically I'm not convinced that Avi Loeb may have considered the anti-tail or not. I mean, it's pretty obvious that comets have anti-tails.
Yeah, it's never been brought up as far as I know. So,
all right. So let me ask Greg a question and Mark a question. Greg first, Mark second. The first question is varying sizes. I've heard that it's the size of Manhattan. I've heard that it's actually very small and just has a large dust cloud around it. So my question to Greg will be, how big is it really? And my question to Mark, and I saw this in a recent article you did, Mark, what is the chemical composition of it, and why would that make it possibly technological or mundane, just a product of the universe? So Greg, explain the size differentials that we're seeing.
So I did look up the size that's been reported just before this meeting, and the range was anywhere from a quarter mile to 28 kilometers. So, and I'm mixing miles and metric there, but it's a huge discrepancy as far as the size. Nobody really knows.
And is that
as far as I've seen?
Is that because of a dust cloud making it look bigger?
Yeah, it's very difficult to get the actual size of the nucleus of comets, as far as I know.
There is one, and I know it's not my time to speak on this, but there is one thing that is important too, is that When we look at comets, they outgas, they give off these jets of material. And with comets where the nucleus is only a couple miles in size, we'll notice that the comet jogs in its orbit because these jets are kind of propelling it along as it goes. What we're seeing with 3A Atlas is that there is none of that acceleration we expect to see. It's called NGA, non-gravitational acceleration. And non-gravitational acceleration is the rocket jets of dust and gas shooting off the comet's nucleus that causes it to move. We're not seeing a lot of that, yet we're seeing this giant coma, this giant cloud around the nucleus. That means by default, it's got to be more massive than we thought it was. Now, it could be just a bigger feather density object, or it could be a smaller high density object, all right, to make it more massive. But either way, it's going to be more resistant to any of its own propulsion that's sending it around in space.
Okay. You guys had some pictures that you wanted to show. We're going to pop up a picture of the
UFO reports come in from around the world. The Mutual UFO Network is there. We continue to explore new cases and build our massive database. We share our information with the world in a number of ways. If you'd like to be part of our investigative team, you are always welcome.
a picture of the comet with the anti-tail. What was the name of the comet again?
This particular comet, I think is the one you're talking about, Greg, was Tsutshin Atlas, which was a couple of years ago.
A year ago.
A year ago. Okay, thanks. Yep. Yeah, well, this is Tsutshin Atlas with its anti-tail, and you should see that. So here you see Tsutshin Atlas. Here is the main body of the comet with its this bright area is called the coma. Well, the anti-tail is this faint area leading down the front, and this is a mosaic of two shots that I did of it. This is the main body of the comet with its dust tail back here. And that nucleus that's inside there is not where that white ball is. That's inside that white ball. And it's so small, you can't see the nucleus if it was exposed right now. Okay, because it's so tiny. It's only a few kilometers across. All right. So clearly that's what's happening. Now, this tail that you're seeing here, this dust tail is the same thing as this. This is actually the back end of this dust tail. Okay, the dust tail is curving around and you're seeing the more distant back side of the tail. That's what causes the anti-tail when it's a dust tail. Now, not to be confused with the other type of tail we see with comets, and that's the ion tail. The ion tail is a blue spike that comes off the comet, and that is always pointing at the sun. The dust tail sort of swings around and lags behind, but the anti-tail is always pointing, or the ion tail, sorry, is always blue, and it's always pointing toward the sun. And of course, as you might guess, it's made of ions. Now, you were going to ask me, I think, about the composition of the comets that makes them either interstellar spacecraft or objects like we understand, like this comet. And comets generally have a greenish glow to them when you look at their nuclei, and that's because of the fact that they're made of carbon compounds with cyanogen, which is a carbon and a nitrogen atom together with another carbon and nitrogen atom. That's cyanogen, and that's cyanide, basically. And so that coupling produces a green spectral glow when you see it in photographs and spectral responses. All right. So the dust tail is sort of reflecting dust. It's just the yellowish glow of the sun as seen through our atmosphere and the dust in the in interstellar space. All right. So this comet, 3I Atlas, which is not this here that we're looking at, 3I Atlas actually has, and I'll just stop that right now. 3I Atlas has cyanogen, has carbon. It has carbon monoxide. It has carbon dioxide. In fact, a healthy amount of it, more than expected for typical comets. A typical comet only has a few percents of carbon dioxide, frozen carbon dioxide. But this comet has a wealth of it, and so that's incredible. It also shows evidence of nickel atoms floating around inside that dust cloud called the coma, that part around the nucleus. And that's unexpected because we don't expect to see nickel without iron when we're looking at this type of stuff. So it's odd to see just nickel atoms and not iron as well. So we also see carbonyl sulfide, which is a another compound, a carbon and oxygen and a sulfur atom combined to each other. And so none of these things are unexpected in comets, but the amounts seem to make this comet really unique, along with its trajectory coming in like it is. And when you're ready, we can talk about that stuff, Bob.
Okay. Recently, I think in the past week, it passed Mars in its trajectory. And I just want to share an image here that the Mars, should be up in a second, the Mars Perseverance Rover snapped a picture that everyone's claiming is a photograph of 3I Atlas, and that it is definitely a cylinder-shaped object, and therefore it must be alien technology. What are your guys' thoughts on this photograph?
You want to go first, Greg?
It's a streak from a time exposure.
It's not an alien spacecraft mothership that's cylinder-shaped.
No.
Correct. I mean, otherwise we, being on the photo analysis team, we would have a lot of spaceships, and all they are is bugs smearing across the lens at a close range, and it looks like a cylinder. So, I don't know that smudge is an actual cylinder for 3I Atlas.
Yeah. And it also may be also that we're looking at one of the Martian moons taken in time lapse with the Perseverance rover as well.
Okay, so we can agree this is most likely a time lapse over several seconds, several minutes.
Yeah, probably several seconds. I don't know how many. It depends how fast it was moving, how far away it was when the picture was taken. Depends on so many things, but certainly several seconds.
Okay, all right. Where do we go from here? You have any more pictures you want to share?
I do. I wanted to talk about the trajectory. Greg, you got something you wanted to throw up there or no?
No, I think the trajectory would be good.
Okay, let me bring that up and show folks what we're talking about. Let me bring up the one that I think is the most illustrative at the moment. And that is going to be this one here that I'm going to bring up. Now, it's important to understand the orientation that we have in space. And this really points that out. Okay, this image here, right? Can you see all that pretty well?
Yep.
Okay, here is our solar system. It's at around a 62-degree angle to the plane of the galaxy, which you see right here. That's the flat whitish area with all the stars and the center of the galaxy represented here. Okay, the North Galactic Pole's up there, South Galactic Pole's there. We're on an angle. Now, 3I Atlas came in along this plane here, kind of like this. So when it did that, all right, the plane, all right, of our solar system passes, or the galactic disk, we pass through this. If you think of the sun as being roughly on the galactic disk at the moment, all right, 3I Atlas came in from here and is coming through here and is going to go out here. And that means that it's going in, and then I know this is sort of a deep projected 3D image that we're looking at here, but it's going to come in and then head out along the galactic plane. And this could be the reason why it's so different and why it looks different. Now, one of the things I wanted to do was to show another shot. This is the James Webb photograph of it, okay, of 3I Atlas. And this is what we're expecting to see right now. This is the kind of the best we can do. Now, this one was taken some weeks ago, and in fact, on the 6th of August. So obviously, we've got quite a difference now. So they'll be looking at it as they can. But we have to also keep in mind that the James Webb is going to be useful only so much because they'll never point that telescope toward the sun. And therefore, we aren't going to be able to capture it in its full traversal because it's going to be moving around the sun in our daytime sky for a period, then in the early morning sky kind of a thing, if at all. So we have to make sure that our telescopes that we use are telescopes that can actually see it. I saw, and this is a good point to make here, I think, I've seen many different things on the internet saying what it is and what it isn't. Okay. And among them, they were saying, well, NASA's gone dark. NASA's not showing any more pictures. NASA's hiding it. No, the daytime sky is hiding it. Okay, that's from people who don't critically think and don't think about where it is in the sky. It's in our daytime sky at the moment. It's too close to the sun. We can't see it. I took pictures of it with our Skyter live stream telescopes. All right. So the bottom line is, right, and this, by the way, this is a photo taken by the ExoMars satellite around Mars. Okay. And this guy right here looks very much like what we saw you show before, Bob. This is an example where the comet has been tracked, and this is star trails of the stars over the period of time that the photo was taken. All right. And so we see this coma around here. And, we're looking at these photos, and of course, they have all this noise in it, but that's what we expect, with these types of telescopes, So, we're getting lots of pictures, but notice that everything is sort of a fuzzy dot that's bright in the center. There's no structure. Okay. It doesn't look like this. Okay. It's not the planet killer in the Doomsday Machine from Star Trek. That's not that at all. Don't you think I know that? That kind of thing with, Decker. Okay. So it's not that. It's what looks like this. It looks like a relatively normal comet. The more we see, the more we look at it as a potential likely comet. Okay. It's not one of these things here. Now, this number is actually very important. 0.005% chance it's natural is not correct. It's not that is a corruption of the original fact that was given. All that was saying that when we looked at this, that's our photograph of it right there. There's a little tiny dash in there. Okay. But when we actually look at this particular object and we look at it in the night sky, it's coming in on an angle like this to our solar system and then going to curve a little bit around the sun and go out like this. Okay. So what does that mean? It means that it's actually above the plane of our solar system coming in and going to be just below the plane of the solar system on the way out. Remember the 3D view, right? So that shows us where it is. Now, right now, it came in from here and it's passing Mars. It'll pass by Venus by I think 80 million miles or 60 million miles. I've got it written somewhere. And then Jupiter, it's going to pass by, but not even that close. Jupiter's going to be here. And Jupiter is the last visit on the way out of the solar system. What the 0.005% is telling us is how likely it is for an object to come in along this path. It's only 0.005% chance that an object will come into our solar system like this. No, it doesn't mean that it's only a 0.005% chance it's natural. It just means that it's a slim chance that this object would come in on this path. So that's an example of the corruption and reinterpretation and reimagining of the actual facts. It's rampant on the internet and in social media. So I've been kind of going at it like a chicken with my head cut off.
I've seen some of your arguments back and forth with people. That brings me to a point I wanted to make. There were two posts I saw this week which amazed me. There's a lot of disinformation out there. One was that it has now sped up to faster than the speed of light, and it has 6 headlights on it. Can you guys elaborate what people are thinking they're seeing, and what's the probability it's going faster than the speed of light, and explain that away?
0.
So,
0 on the headlights. Yeah.
Agreed.
It's clickbait.
Yes, that's what I was going. Yep.
Yeah.
So people have to be really careful. Spacecrafts don't even need 6 headlights in space, and pretty much what they're seeing is the nucleus of the.
That's right.
Yeah. All right.
They're seeing that coma, and when they say there's 6 headlights on it, again, as Greg just pointed out very aptly, it's just clickbait.
Yep.
No headlights.
And
sorry to say.
What's the scientific basis for it not being faster than the speed of light? All of the reasons why that people are being lied to about something like that. Explain that away scientifically.
That's actually very easy. We have the mass energy equivalency formula called E = mc². Well, that's not the full equation. That's an equation for an object moving slower than the speed of light. Something moving faster than the speed of light, well, you got to add a couple other terms in there. But let's just consider that if an object like a mass is trying to move the speed of light, it becomes pure energy.
Mm-hmm.
And it would no longer be a viable physical object that we could see. That's the light speed is the speed limit in the universe, and it applies only to energy. It doesn't apply to physical things. Physical things can't go the speed of light ever. Now we can go 99.99999, etc. times the speed of light, right? We can get right up close, and that's fine. But we can't ever be at the speed of light. All right. So, and nothing in the universe moves faster than the speed of light. So that right there, okay, only light moves the speed of light, and everything else is slower than that, as far as we have seen so far.
I was going to get you on that.
You weren't going to get me there.
Yeah. I was thinking about it.
Okay, then let's wrap it up here. Avi Loeb claims that it's a 4 in 10 chance that it could be an alien spacecraft. Each of you, I'd like your opinion. Greg, on a scale of 1 to 10, how likely is it that it's alien?
You said 1 to 10?
1 to 10.
1.
Mark?
Well, it's alien in that it came from outside the solar system.
That it's a craft, an alien craft. On a scale of 1 to 10.
0.
I knew you were going to say 0.
Yeah.
You don't get 0. You get 1 to 10, pal.
Okay, 1.
1.
1, and you're lucky to get that.
Yeah, Mark.
At this point, everything we're seeing shows us that it's looking more and more like a comet. So I'm going to say 1 as well.
Okay.
All right. Now, the only reason Avi said 4, I think, is because of the true anomalies. Like, what's this nickel emission? What's the trajectory being so like parallel, like I showed you, and it's going to visit certain planets. If we were sending a probe to another solar system, we might visit the larger planets if we knew they were there. We might steer clear of the Earth if we believe in the prime directive of Star Trek. And if you think about it, we're doing that now with the Juno probe at Jupiter, all right, and with Cassini at Saturn. We ended the Cassini's life by plunging it into Saturn's atmosphere because we didn't want to affect Enceladus, which was one of the nearby moons, by chance. We didn't want to contaminate it. Same thing with Juno. We're going to plunge it into Jupiter's atmosphere when we're done with it, so it doesn't affect Europa, a potential moon of Jupiter that could have life under that ice mantle. So, would we choose to avoid a planet with life on it? Well, sure we would. And I'm sure that, Avi may be thinking these kinds of things. I can't speak for him, but it's possible that we're just trying to avoid, contaminating potential planets. If this is actually a probe of some kind, I too would want to make it avoid the object we think has life on it, because what if we accidentally hit it? And that means that if that's true, then these potential beings, which I don't think are present in this particular case, but if there were potential beings, I think that would be something that shows that they're stewards of the universe and want to keep everything, uncontaminated. But in this case, I think it's just lucky that it's going to be about 170 million miles from us at closest approach.
Well, if it's traveling at the speed of light a couple hours after someone discovered that, we wouldn't even see it.
That's
Right.
right.
So if they can still look at it, that means it wasn't traveling at the speed of light.
I was hoping to get that answer out of one of you guys.
Yeah, that's an obvious thing.
All right, so let's leave it there. All right, I'd like to thank you both for coming on. MUFON has been doing the Air Force's job since 1969. We'd appreciate a like or a share of this show. If you see something, you can go to our website, www.mufon.com. We have a red button up in the upper right-hand corner where you can report a UFO, UAP, or a second button if you believe you've been abducted. Membership is very inexpensive, starting as low as $6. You get a monthly magazine, newsletters. You can join our internal social network. And I think most importantly, you get access to our 145,000 case database. So if you're interested, we'd love to hear from you. We'd love to make you part of our team. And guys, thank you very much. Hopefully we can do this again real soon.
I've been in MUFON since I was 11 years old. No lie.
Thank you for your long time service. Hey guys, good night.
Thank you.